Today we will be covering the part three of the series. So the series is named Discover Three Ways to Deploy Apps in Cloud. And before the stream, we already covered the previous two approach using VMs and managed services. And today we will take a look at the serverless approach. And welcome everyone. I just want to make sure that everyone had joined in and then we can get started in a minute. Hi, everyone. Let me know in the comments where you all are joining from, and I would be more than happy to have you all in the stream. And hopefully, you will be able to uh, get some new approach and learn new things today in the stream. Hi, everyone. Welcome to the stream. Welcome, everyone. All right, then, let us get started without any delay. I hope you all can already see my screen. So let us go with the slides, and then we will come back to the demos. Hi, everyone. I'm Sagar, and I'm a coach here at Major League Hacking. And professionally, I have been working in the DevOps and cloud native space for over 2 years now. I'm also doing my master's at Technical University of Munich. And last week, I had a super fun weekend in Porto, and I am having a really good break from my semester. So yeah, enjoying my break as well. If you want to connect with me, then I'm mostly active on Instagram and Twitter. So feel free to connect with me and also do follow the MLH social handles for up-to-date information about all the events and all the things that we do here at MLH. Once again, welcome to the Global Hack Week. I know today is the final day, and I hope you all are already had a lot of amazing sessions and learned a lot and also had some fun throughout the mini event. So welcome to the last day and hopefully you'll get to learn something new today as well. One super important thing is the resources that I have prepared for you. So all my three parts of the technical stream, you can find the resources in the specific link. It's a Notion page with all the commands and snippets and the instruction that you can also use to follow along with the stream. And just to help you make it easier to follow along, I have prepared this guide. Make sure that you go ahead and check out this link. It's mls.link/deploy with Sagar. So that's the link, and I can also put this in the chat if you want. Let me go ahead and actually do that. Hi, we have Rishikesh in the stream. Welcome to the stream. I hope you had a great time this week. Let me put the link in the chat as well. All right, that's the link. Yep, you can go ahead and check this out to get all the session resources. Just to give a brief overview of what we did already and what we are going to do today, this was the part one of our series. Please note that the today's part is completely independent of the previous two. So if you could not join my previous two sessions, then it's totally fine. You can always follow along just for this part as well. These are prepared as a standalone sessions. So you can go ahead and just follow the session if you want. And if you want to rewatch the first two parts, they're already live. They're recorded on the MLS YouTube channel. Yep. And the part one, we covered about the virtual machines and how different cloud service model works. We also talked a brief about the different Azure services, and then we deployed a full-fledged MERN application, how you can use MERN application stack and deploy that within the Azure virtual machines. We did everything from our own on scratch in the VM. So that was the first part. This offered us great flexibility and customization option, but it does come with a lot of hassle of setting up the VM, the networking configuration, setting up your OS and everything. So all of that you needed to do by yourself. Then we moved on to part two, where we used the managed services instead of using VMs ourselves. So we use the Azure Web Apps for our backend and the static web app for our React application. And then we also automated the entire deployment process using GitHub Actions. So all of those were automated, and we had the managed services that took care of a lot of things that we needed to do by ourselves otherwise. And then we used the same one application, but this time we deployed it using managed services. So that was part two. And even we showcased how we can use a custom domain once your application is already hosted on Azure. So that was part two, and this is today. So we are going to take a serverless approach of deploying our web applications. So we do have a different web application, but it's very similar to what we used in part one and two. And again, we will be using the static web app, which is also a serverless offering from Microsoft Azure. And then we are going to use the Azure Function app. So this is this main serverless component that we will take a look at today. And it's a function as a service. It's an event-driven service where which gets triggered based on certain events, and it just runs your code out of the box. You don't need to even set up your platform. Everything works smoothly, and we will see how this works. And then we will also take a look at the Azure Cosmos DB. So it's a proprietary database solution by Microsoft Azure, but it does support the MongoDB API. So instead of using MongoDB Atlas that we used in part 2, we are going to use Azure Cosmos DB because it comes with a lot of other benefits as well, and it is compatible with the MongoDB API. So you don't need to change your application code. If you have a MongoDB in your application, if you're using that, then it works out of the box for Azure Cosmos DB as well. And then we'll also take a look at the Azure Key Vault, which is used to store secrets that is needed by your application. So remember in part 2, we injected the secrets such as the database connection string and the ports and everything that we needed. Also the API URL for our front end directly in the environment for the Azure Web App or static web app. But now we are going to use Key Vault to make it super secure and do it the cloud native way. And then we'll also take a look at the Azure Developer CLI. So this is what we will use to deploy our infrastructure as code. So instead of setting up all the Azure resources from the portal and by clicking and going and clicking on different things, we are going to just write everything that we need, even the not just the application code, but also the Azure services that we need and how we want to set up. We will use the infrastructure as code tool. There are a lot of other tools as well, such as Terraform and other tools in the market, but we are going to use Bicep, which is native to Microsoft because whatever we are using today, it's based on Azure, so that makes it super easy. So we're going to use Bicep and see how it helps us quickly spin up infrastructure. So with just one command, we will have all different 9 to 12 Azure services spinned up for us. So that's going to be the part 3 of my stream. So let me check the comments if we have anything. All right, no. And then let's go back to the slides. So let's start. Just to give once again a brief overview of all the services that we will use today. So first we are going to talk about the Azure App Service. And this is a fully managed platform as a service by Microsoft Azure, and it is used to host our applications, mostly the backend stuff. So Azure takes care of the infrastructure for us. So we don't need to set up the actual VMs or configure the operating system, update the drivers and all those things. Those are taken care by Azure for us. And it supports a lot of runtimes and the frameworks. So from .NET to Java to Node.js to Python, all of these are supported. And they are adding new framework every year. So it's a fully fledged matured service. It does come with a CI/CD support, so you can integrate GitHub Actions right within your workflow or even Azure DevOps, so that whenever you make any changes to your application repo, then it gets automatically synced up with your live application on Azure. Not only the web apps, it also supports mobile application and just the bare REST APIs. And the documentation, if you want to have a deeper look into Azure App Service, is in the repo link. All right. So next up, we have the Azure Static Web App. So if Azure App Service was for the backend stuff, so Azure Static Web App is for the front end stuff. So these are for serving static contents, such as the build React or Vue.js or whatever framework that you use. So once you have the build assets from those frameworks, you just get the plain HTML, CSS, JavaScript, and the images assets at the end. So you can use the Azure Static Web Apps to host those actual content. So it does uh, support the CI/CD actions. So like same as for the web app, it also supports automated CI/CD with GitHub Actions or Azure DevOps. So we also can access Azure Service in a lot of different ways. So we already saw how we can use Azure Portal, but there are also a lot of other ways. And the one that new thing that we're going to use today is going to be the Azure CLI and also the Azure Dev CLI. So that's the new thing that we will use today. So we are going to manage and create Azure services using the CLI. And there are also a lot of other ways, like you can have VS Code extensions and that you can interact with the Azure services through extensions. You can also use the actual REST APIs provided by Azure. And then one new service that we'll use today is Bicep, which is an infrastructure as code tool. So we will write what service we want and how we want it to configure in a code, and then we will use that as well in our workflow. We'll talk about that in a moment. Okay, next up we have the GitHub Actions. So GitHub Actions is a CI/CD workflow tool. It helps you to automate your software workflows right from your repository. So you need to define different jobs and steps. So just think of it as a collection of different steps that is needed to package, build, and then finally deploy your application. So all those different steps that you needed to perform manually, you just write it in a workflow file with different jobs and steps, and then GitHub Actions does it for you. So these are event driven. That means that the workflows that we write gets triggered based on certain events. The events could be anything from a push to a GitHub repository to creating a pull request to having certain commits and labels. So whenever these things happen, let's say you push a new change to your main branch, then you can trigger or you can configure GitHub action to be triggered on that. So whenever someone pushes anything or merge your PR to the main branch, then the action will be triggered, and that action will, let's say, build your Java application or your React application, and then publish that application to a live web um, services hosted within Azure or any other cloud service provider. So that's GitHub Action for you. You can build, test, and deploy directly from GitHub. Um, the other service that we're going to use today, it's going to be the Azure dashboard. So this will help you quickly get an overview of the different metrics for your applications, such as the number of active users who are accessing the web application. You can see it over a period of time, so you can get an idea of what's your user traffic look like. You can also see the number of failures or failed requests. You can see the response time, delays, the process utilization, CPU and memory utilization, so that you can have everything in one dashboard, so that you can quickly have a glance and see if you need to change something or if you need to adapt to a new request. So you can get an overview of how your application infrastructure is running and how your application is performing with the help of Azure dashboard. So we will have this set up today as well. Next up, which I briefly mentioned previously, so we're going to use the Azure Dev CLI. This is mostly for developers who are developing apps with Azure. So you can define what you want to build. You can create different services within your application. So just like the Azure portal, where you do everything manually by clicking on the services and entering a lot of details, we do that right now with code, and we can use that in combination with Bicep to make sure that our application is up and running. So we'll use this and Bicep together to make sure our application is deployed smoothly. Yeah, just I mentioned Bicep, and here it is. So it's infrastructure as code tool. That means we will define every resource and your services that we need in form of code. So here in the example, you can see that we are trying to create a storage account. So you need to create a resource for it using the documentation from the Azure Bicep. We pass it different parameters. In this case, we pass it different location and all those things. And then once you have this, we also define the SKU of what type of storage account we want. And then once you have this and you apply it with the help of Azure Dev CLI, then the Azure will create this resource for you. Of course, you need to authenticate to your Azure account for this code to run. But once you do that, and I will show you exactly how you can do that, then the application will be, sorry, the Microsoft service will be up for you in your Azure account. So one other benefit of using Azure Bicep or any other infrastructure as code tools such as Terraform, which use templated version, is that you don't need to define the order of resources creations. And normally, for example, if you use a non-template infrastructure as code tool, then let's say you have 10 different Azure services that you want to create, and you just give the command to create them. But the infrastructure as code tool might be confused because it tries to have multiple put calls at the same time. So it does not know in which order the services should be created. But most of the time, we need certain services to be created in order. For example, we need the database service to be up and running before we deploy our backend, because the backend needs to connect with the database. So that means the database has to be up and running first. Likewise, for our front end, we need the backend to be up and running first because the front end tries to connect to the backend. So we have a specific order of resources creation, but that is super easy with Bicep because it compiles all the requests and it knows the order of creation of the resources. And with the help of your resource manager and the provider, it creates those resources for us in a specific order in a single call. And that's super nice to have. So this is a sample of the Azure Bicep file that we will use. So you can see that in the example, we are creating a resource group at first, providing it with name, location, and the tag. And likewise, we are using different modules for our front end as well as the back end. So we will talk about this in a moment. So that's just for you for some overview. All right. Let me know if we have any comments in the meantime. Okay, so we have a question. Azure Cloud Services is paid. So to host any projects, we need to buy the plan. Yes, Azure Cloud Services is a public cloud service provider, but in our case, we are going to use a free $100 credit that Azure provides for students. So I have all those links in a resources guide where you can sign up for the student account. And if you have a student email, you get $100 credits. And that's what I'm using for the demo as well. I will show you that in a moment of how you can go ahead and claim that as well. So yeah, you don't need to pay anything out of the box, and you don't even need to enter your credit card information to sign up for your student account. And please use that to avoid any cost that you want. But let's say if you are an organization or if you are hosting your own project that is used by a lot of people, then you need to pay. Although like there are different Azure services which provides you certain limit to their free tier, so you can use some services and the basic version of their services, some standard limits within limits. But most of the time, if you are deploying it for production use case, then you need to pay a certain amount, but not for our demo. So I hope that makes it clear. Yep. All right. Thanks for the feedback, Pallav. Let me know if you have any questions throughout the session, and then I can answer all those questions for you all. Great questions, by the way. All right, let's go back to the slides and now take a look at the actual architecture of the app that we are going to use today. So all of the resources that we are going to use today, it's going to be within a single resource group. So think of it as a collection of different resources for a single project. So in our project, we have first the static web app that we will use. And in this case, we are using a React application. Uh, for your disclaimer, the app that we will deploy today, it's a to-do application. And then I'm going to use the sample code provided by Microsoft Azure itself so that it's easy for you all to understand and also get a copy of it whenever you want. So all of the repo link is also in the guide that I have provided. In the link, if you go to the link that I have shared with you all, you will be able to find that repo link. So we are going to use the static web app to deploy our React application. And then we are going to use Node.js for the backend, but the Node.js will be deployed as a function app. And we are going to use the API management service. It's going to act like an API gateway. So between front end, the API gateway will handle all the requests from the client to the backend, and the function app will take care of hosting the actual Node.js APIs. So we are going to use the function app to host and run the Node.js APIs, but the API management service is the actual API gateway that is connecting the front end to the client to the back end. So API management will act as API gateway, and the function app will run our will execute our API request code based on the requests. So our Node.js backend, it does need a database. So we are going to use the Cosmos DB API for MongoDB. So we are going to have the Azure Cosmos DB service as well. And since it's compatible with the MongoDB API, so that's going to be totally fine for us. And then we also need some secrets. For example, we need the database connection string. And normally, if you know, then the connection string comes with a username and password. I can show you that in a moment when I actually do the demo. So normally we need to inject the API for MongoDB URI. So the MongoDB connection string within our application, the Node.js application, and that normally expose the username and password. So what we did previously in part 2, we injected that as an environment variable in the Azure App Service, and that worked fine for us. We never push or commit the actual secret to the GitHub repo. That is a super bad practice. So we should never actually commit anything that is secret on the repo. So we just indicate it as a runtime environment variable. But today we are going to use Key Vault, and that's the industry standard practice of managing secrets. So we're going to store the secret within that, and the function app will reference that secret to get the connection string. So that's going to be the security part. And then we also need a storage account for our function app. So whatever temporary storage that our function needs, so it's going to use the storage account for that, and also the to actually store the code content or the actual code, it needs the storage account. And finally, we are going to use the Azure Monitor as our monitoring service. So this is what we provides all the metrics such as the CPU utilization, the memory utilization, the traffic, and everything that our application possesses. And we are able to see that through the Azure dashboard or the Azure application insight services. So this is the overall architecture of our application that we will be deploying today. I hope that makes it clear. Let me check the comments if we have. All right, so we have a question. Can we also use Flux or Django? Definitely. You can use any backend that you want, but the demo that I'm going to show you today, the application code that I have is with Node.js and React, but you can use Azure Service for any type of backend you want. So if you have a Node.js, if you have a backend with Django, or if you're using Flux for your API management, then you can also use that. But you just need to tweak it a bit. But Azure Functions as well as the Azure App Service, if you are following the part 2 approach, all of those are compatible with a lot of different tools. So with Java, with .NET, with Python, so you can use any of the language tool that you want. I hope that makes it clear. So next up, let's go to the actual demo. Let me quickly share my screen. Just a disclaimer, bear with me because my secondary monitor is broke down. So I might be switching up my screen here and there. So there might be a bit of a lag. So please let me know in the comments if you are facing an issue or if my screen is not sharing at times. That happened. That happens sometimes. So please let me know if you face any issue with the screen sharing. But I will try to make sure everything is shared with you all. So let's go ahead and all right. Let me share the screen, stop sharing, present, and then I'll share my entire screen with you all. Bear with me for a second. All right, I hope you all can see my screen now. So like I mentioned, the first thing that we need today is the Azure Developer CLI. And please go to the link that I share with you all. For example, this specific Notion page, you will see once you go to the link mls.link/deploy with Sagar, and it has all the prerequisites that we need. So we need a Microsoft Azure account to get the student credits. And also, by the way, if you have not checked into the event, please go ahead and check in to the event for part 3. You just need to register. I hope all of you already had done that. If not, you can still register, and you should be able to see a check-in button over here. And once you do that, you should be able to get your points. Today is the final day, so go ahead and grab your points for some swags from our team. So coming back to our prerequisites, we need the Microsoft Azure account. So the link is right here. So if you click here, then you can just use your student email ID and then sign up with Microsoft Azure. You will get $100 free credits, and no credit cards is required, as I already mentioned before. And once you are there, you can go ahead and access the portal from portal.azure.com. So that's the link for our Azure portal. And once you are in the Azure portal, you can always check your credits from the education tab. So you can either search for education from here, or if it comes before, then you can go ahead from there. And once you are in the education tab, you should be able to see the remaining credits. So for me, I still have 93 credits remaining. So I have just used $7 out of now. So it's going to be more than enough for all the projects or demo projects that you want to host. But please make sure that you delete the resources once you are done with the project. Otherwise, the cost will keep on incurring. So once you have completed your project or the demo, or if you are just following along with me, then please make sure you delete the resources that you have created. And it's going to be super easy with the Bicep tool, because we will not create anything from the portal. We'll use the code. So it's going to be super easy to delete the resources within just one single command. So yeah, just giving you information about that one. Um, Next up, we don't need a MongoDB Atlas account for this part. We used that yesterday. And the next thing that I want you to install is the Azure Dev CLI. So this is super important. So make sure that you go ahead and install the Azure Dev CLI. So the link is here to install. And based on your operating system, so if it's a Windows, you can use Wingate. If it's a Mac, you can use the Homebrew tool, that which is what I'm using as well. And then if you're a Linux, then you can use the script and just follow the instructions here to install the Azure Developer CLI. So all of the instructions are here. So make sure you install the Azure Developer CLI. And one more tool that I recommend you to install, which is not in the link, is GitHub CLI. So sometimes when we use the Azure Developer CLI behind the scene, it will use GitHub CLI if we are, let's say, trying to use the GitHub Actions to automate our deployment process. That we will do at the last part of the demo. It behind the scene, try to use the GitHub CLI. So you can also install the GitHub CLI if you want. You can have the installation instructions over here, but that is not mandatory though. Like if you want, then you can. That makes it super easy. So for the part 3, here is the repo link that we are going to use today. So you can go ahead and click on the template. So it will open the Azure sample template repo, and this is the actual repo that we will use. Don't be overwhelmed by the code. I'm going to explain you the thing that you need to focus the most. The focus today, once again, is not on the actual application code, not on the Node.js and the React application that we have here. We are actually going to focus on how different tools are used, or how we can deploy those applications to cloud. And in this case, it's going to be Azure. So the focus is on deploying the application using the infrastructure as code tool, rather than how you can write the application. So that's just a disclaimer for you all. So this is the application code. So you can go ahead and use this template and click on create a new repository, and just choose your account as the owner, and that's going to be a repository name. So that is going to be DSW serverless. I'm going to name the repo as DSW serverless demo. Um, and then I'm just going to make it public. So I'm going to create a repo. So this will create a repo out of the template. And just make sure you clone the repo to your local machine. So I'm going to use SSH for this one. And I'm going to open up the VS Code. So let me open up the VS Code, and I'm inside the GSW folder. So let me go ahead and clone the repo. I think this site should be enough. All right. And once it is cloned, let me go to GSW serverless. All right. And I'll open it in VS Code. So I'll close the previous window and just open this one. All right. So this is the repo that we have cloned. And make sure that you have the Azure Developer CLI installed. Quickly close all of this tab. All right. And here, just to make sure you are using the Azure Developer CLI, just type in AZD, and you should be able to see all the instructions that we have, and not something like AZD is not found. So that means your Azure Developer CLI is not installed. So I have the Azure Developer CLI already installed. And then once you are in the Azure Developer CLI, the next thing that you are going to do is to authenticate. So for that, you have to use the Azure AZD auth and then login. So this is the command that you need to use to log into your Microsoft Azure account. So this will connect your CLI with the Azure account, and it will open up your browser, and you need to select your Microsoft account. So for me, it's my student email. So I'm going to use that and just click on access if you're doing this for the first time. And then once your authentication is done, um, you can go ahead and return back to the CLI, and you can see that you are now logged into Azure with your student email. So that is all that we need. So we have the repo code. We have authenticated to the Microsoft Azure account with the Azure Developer CLI. So those two things are set. And also you can install, if you're using VS Code, you can install the Bicep extension. And this will provide you some language support for the Bicep files that we have. though it's not mandatory, but it just gives you some additional benefit of understanding the bicep syntax, and tells you if your bicep syntax had some errors or something like that. So just make sure that you have that extension installed if you are using VS Code or any of the VS Code extension supported repo. So let me come back to the stream. Yeah, I will be sharing my StreamYard stream as well, so bear with me for the second. Um, oops, did my was my screen not viewer? Okay, all right. I think I forgot to add my screen on the stage. So let me come back and once again tell you all the things that I did just before we get started with the repo. All right, let us go back to the um, CLI. So I just what I did is yep, I think you can see my screen now. So what I did right now is I went to the guide, and here is the repo that we need for our demo. So we need to clone this specific repo. So we cloned the repo from here. And then once I cloned the repo, or you can actually use this template to create a repo in your own account, and that's a better way to do it. So I have already done that. I used the repo to create a new repository, and I named it as CSW serverless demo. And so this is generated from the Azure templates. And then I cloned the repo that I actually own, because I want to make some changes to this repo. And when I want to do that, I need it on my own account. So I did that, and I have already gone ahead and cloned that. So just make sure you are you have cloned and you are inside that repo. So that is all that we have done till now. And then what I have done is I have used the AZD auth login, and you can see that you can sign up with your student account. And once you click on your student account, you should be able to log into Azure from your Azure CLI. So that is all that I have done till now. And now we are actually within the repo. So that is all that we done till now. So we have the Microsoft Azure account, we have the Azure Dev CLI logged in, and now we can actually start with understanding the code that we have here and how this works and how we are going to deploy this to Microsoft Azure. I hope that that is clear till now. All right, we have one more question. Can we use Flux or Django? That I have already answered. Um, so you can use any of the repo that you want. You can use any of the framework that you want. For example, you can use Python based like Flux or Django. You can use Spring Boot for Java, but you just need to tweak your Node application or your Flux application just a bit so that the application app service in Azure support that. So once you have tweaked the application configuration properly, then you should be able to use all the applications. So let us come back to the repo. And now let us actually go ahead and use the code to understand how this works. So we have the application code here. So in the SRC folder, we have the front end, which is the web, which is in the web folder. And this is actually, if you go to SRC, so this is a React application. So you can see all the React files over here. So that's the React application that we have locally. And you can, if you see the package.json, so it's using Vite as a development environment and to also build the application. So that is what we have over here. And then it's using TypeScript instead of the plain JavaScript. So that's the front end of the application. And for the back end, it's in the API folder. And if you go to SRC, then this is the actual backend. So in this case, Node.js, which is written in TypeScript, and you can find all the routes or the API routes of our application over here. So we have the routes for getting the whole list of the to-do. We have a routes to create a new list. So post routes, get routes, all the basic CRUD routes. We have a put request, we have a delete request, and we have a lot of other API routes as well. So that is the backend of our application. So SRC as API hosts the backend, while the web folder hosts the front end. The next thing that it's super important here is the Azure.yaml. And this is what is used by our Azure Developer CLI to actually run our application. Let me make sure that the stream is running fine. All right. Yep, the stream is running fine. And then you can see that it's a YAML file, and we structure it in different steps that the Azure Developer CLI will look for. So first, we define the name for our workflow. So in this case, we just named it the same as the repo to Node.js MongoDB SWA function. So this is from the Azure template that we got. And we have just the metadata of the template that the Azure has provided. You can put any value that you want over here. Then the Azure Developer CLI will use this specific workflow steps. So first we have the up workflow, and it's using two specific commands. So first it is using the azd provision command, and that will provision all the Azure resources that we want. And if you now think of what are the different resources that we want, so all of the resources that we need are defined within the infra folder. And if you go to main.bicep, then this it is using bicep to create all the infrastructure. I will come to the bicep file in just a moment. But before that, let us go to the services that it will create. So we have two specific services that is needed by our application. So first, the web services, because remember, we need the backend to be up first, and the web is actually the front end. And then we also have API, which is for the backend, but the order will be defined by the bicep API. So even if we have web at the beginning and then API at the second, when we run the bicep pipeline, it will create API first because we need backend first. And even before that, it will create the database and other services that is needed by the API. So it does not matter how you define the services over here. So then we provide it with the actual path where the bicep file is located. So that's going to be the uh, project parameter, and we have defined the web services. It's using the src/web. So this is the actual source code for our front end. So it's going to use that, and it's also we need to define the final build folder. So remember, if you are using Vite, then once you run the React in the build, you can see that it's using Vite build. So when you run npm run build, it will create a dist folder within the web folder, and that will contain all your static assets, such as the HTML, CSS, and JavaScript that is used in production. So that is why when we go to the azure.yaml, we need to provide it the name of the folder, which will be used for the production build. So it's going to be dist if we are using Vite, and this is the source code. The language is going to be JavaScript, and then here we define what type of Azure service that we want to run. So we need to define it as static web app for the if we are using a front end application. And then it is going to create and run some hooks in this case. And here it depends on what type of cell we are using. So if it's Windows, then it will run the PowerShell. And if we are using a Linux-based POSIX environment, then it's going to use the shell script. So here we are doing nothing, but we are just injecting the API URL because our front end needs the API URL to connect to the backend. It gets the API URL from the environment variable of API base URL, and this will be clear when we understand the bicep file that we have over here. So just bear in mind that we are trying to deploy a static web app in Azure, and we are using the dist folder for getting the static contents once the React app is built. We are defining the language. We are also defining the static web app as the type of service that we want to deploy. And then we are within the build variables, we are defining a variable named Vite API base URI. This is needed by our front end. And then the value for that API URL we will be getting that from an environment variable, because remember the front end needs to connect to the back end, and we need the API URL for that, but we don't have it right now. We will only know the API URL once the backend is already deployed on Microsoft Azure. Then we will get the API URL. So we will see how Azure Bicep does this for us. And likewise, we are also getting the application insights connection string. So we need one more environment variable, and we are also getting that from the environment variable value. So we will get that. And if you see for the POSIX, it's also similar. It's just using a different type of cell. And post deploy, since when we try to access the environment variable, it is trying to get that from the env.local file. So it injects, it creates an env.local file with this environment variable, and that is how the front end injects that. And once this is inject, after the deployment is done, it just removes the same file because that's a temporary file. We don't need it once the application is already built and running. So that is for the front end service. So this was the actual front end service, and this is for the API. So that's going to be the backend service. And here again, we need to define the path for our backend. So remember, the backend is application source code is within the src/api folder. So this is where the backend lies, and it needs to have the package.json um, within the directory of the src/api. What we define over here, the path needs to have a package.json, and then we also define it as the JS file because it's using Node.js. And finally, um, we need to define what type of service do we want. So remember here in the host parameter, we use static web apps, but for the backend, we are using the Azure function. So the value for host will be function instead of static web app. I hope this is clear. So this is nothing, but we are just defining what type of Azure services do we want till now, the main services. So first, we have defined the static web apps, and then we have defined the API. We need to provide it with the application code uh, path and all the types of parameters that we need. And now we will actually see the bicep file to understand the infrastructure data as a whole. But remember, it does not matter the order you define here. So I could have placed API before the web, but Azure Bicep will handle the order of creation for us. I hope that makes it clear. Um, all right, let us go back, and then in here, let us see how this works. All right, so let me go back to the bicep file and see how this works. All right, so I have opened up my bicep file, and let us actually go ahead and run the bicep command in the meantime when we explain our application, right? So let us go ahead and run is it the up. So that is the command that you need to run to access your application. So let us go ahead and do that. Is it the up? And now we need to define a new environment name. Let us name it as GSW um, serverless demo. So that's going to be my environment name. And then I need to select the subscription for my account, and I just have one. So I'm gonna press enter for the first one. And here you need to be very careful because this template does not support all the regions. And here you can find the list of supported regions. So these are the list of supported regions. So just select one of these. And for me, I'm going to select the East US2 option. So I'll just scroll down a bit, and I should have the East US2 option somewhere. Here we go. So I selected the East US2 as the location. You could select one of these 5 options. And now it will go ahead and try to create the resources that we need for our application. And now let us go ahead. In the meantime, while this is executing, let us go ahead and see what are the service that the bicep will create. So this is how a bicep file looks like. So it is defined under the infra folder, and let's go to main.bicep. And then we can understand how this works. So first we define a target scope. So this is on what scope the services should be displayed or deployed. And this is the subscription scope. And then we define different parameters. So first we have the environment name parameter that we just defined, right? Because when we created when we launched the azd up command, it asked for an environment, and this environment is passed as a parameter over here. So that's the environment name parameter. And it is used to generate a unique hash for all our resources. So that's one, and you can define a minimum length for this parameter or a maximum length, as well as give a description for this one. Likewise, we have a location parameter, which we also selected as East US2. So that's the Azure data center location to deploy our Azure resources. Then we have a lot of empty string parameters. So these are the default values are empty, but we will pass the values or use some generators to generate the random values for this specific services. So we have API service name as a parameter. We have a lot of other things like Azure Application Insights name. We have the name for our service plan, for Cosmos DB, for Key Vault, for resource group, for web service, and for API management service. So these are the other thing. And we have a parameter for using if we want to use API management or not. We have the API management SKU parameter, we have principal IDs and a lot of other things. And then we have some variables. And this it's just used to get some abbreviations from the abbreviations.json file. So just to make sure whatever service we are going to use, for example, if we are using container apps, then it's gonna use CDAS as the abbreviation. So it's just to make things a bit easier, we are loading the abbreviations. And the resource token is used to generate a unique name. So you can see that we are creating a unique string out of the subscription ID, the environment name and the location, and then we are converting that to lowercase values and use that to name our resources. So just to make sure that our application resource names are unique, we are using the resource token, and we are providing a tag with AZTENV name and the name of the environment as the tag for all of our resources. So the first thing that we need, if you go back to the slide, you can see that all of our resources, the static web app, the key vault, the function app, the storage, all of these are within a single resource group, right? So we need to create a resource group first. And for that, instead of going and clicking on the Azure CLI, we create a resource in this way. So we have to define a resource and name of the resource, and then we need to define the Microsoft Resources API path, and the version will be 2021-0401. So we get this from the Bicep documentation, and then we name the resource as resource group RZ in this case, and we pass it with three different parameters: name, location, and tag. And you can see that for name, if the resource group name is already passed as a parameter, it's going to use that. Else, it's going to create a resource group name by concatenating or adding the resource group and the environment name variable. So that's how the resource group is created, and it's also going to inject the tags that we have over here. Then for the front end, it's using the web module, which is inside the dot slash app, which means just within the same directory we have an app folder, and there should be a web.bicep. And this is what is actually using building the static web app. And this, we have some other folder like core, and then we go to host, and within the static web app, for example, so this is the actual list of resources that will create the static web app, but we have the wrapper around it. So we don't need to go in that depth. We can just take a reference from web.bicep, and we are passing some other parameters. And we have, once this resources is created, we have certain outputs. For example, the service web name and the service web URI. So this is the URL of the application of how we are going to access our application from the browser. So we are going to get that as an output. So parameters, modules, which will actually create the resources. Modules is nothing but a combination of different resources, and then the output. So if you want to see how this model is creating the resources, just go to the path of the Bicep file, and here you will see how it is creating the resources that it needs. So that was about the Bicep file. So let me go back, and that was about the front end. So we are passing it again the name, location, and tags. And the name is web. We are using the resource group. We are passing in all the resources. We are using scope as RZ to make sure that all these resources are within the same resource group. I hope that is clear for you all. And all right, I don't have any questions at the moment. So let us go back to the module. And then we have the application backend module over here. So we are also passing the name, the scope, and a lot of different parameters. But in this case, we also need to pass different application settings. So we have passed in name, we have passed in the location, which is going to be the East US2. We have passed in the tags, the application insight name, and you can see that the application insight name, this specific module has a parameter application insight name, and it is getting, we don't pass this as a parameter. It's getting this from another module. For example, it's getting it from monitoring module, and if you click on that, we have in down the file, we have something called the monitoring module. So this is going to create a monitoring service for us in Microsoft Azure, right? The monitoring service, and the output of this module, if you go to this specific module.bicep, you can see that on the output we have the application inside connection string as the output of this module. So once this resources is created in Microsoft Azure, it's going to output this specific variable, and that is how this module will get that output. And since we are referencing this module and the output of this module in our backend, so monitoring dot outputs, and the monitoring service has the application inside connection string or the application inside name. So we can use this as a parameter in another module. So that's a really important information that you all need to remember. So we are going to we can have the outputs of other module as a parameter to one module. So that is a super important information that you all need to remember. So for the monitoring module, we are taking its output. And if you go to monitoring.bicep, we see that there is an output called application insight name, and we are using that as a parameter for this one. Similarly, for the app service plan, so there should be an app service module. Yeah, there is an app service module, and this is used to create and um, host our function app and to group application within the same payment plan. So whatever application is under the same app service plan, they are going to be billed in the same way. So it's going to use our credits and the SKU in the same way. So that is how the application plans works, and we are using the output of that because we need that for the backend. And you remember the backend is using the Azure function, so we need to provide it with the app service plan, and we are using its ID. So if I actually want to confirm that, I can go to app service plan, and if I can open the file, then there should be a output name ID. And exactly here you can see that there is output name ID. So once this resource is created, we will have an ID of this resource, and we are using that as an output. So that is about the app service plan. So we will create app service plan, use its ID as an output. Likewise, we need a key vault. So we are also going to create a key vault from the key vault module. And then we are passing it different parameters of location, tags, and principal ID. The principal ID is nothing but the Azure service principal, which is used to authenticate between the Azure resources. So we can create a single principal ID, and we can provide it with different permissions of what uh, the principal ID can access. And if we pass that principal ID to different resources, then let's say resource A can access resource B within the same account or different account if the service principal is configured properly. So that is how we pass on permissions between services in Microsoft Azure. So that is about the backend stuff. So we have taken output from the key vault. We have also taken output from the storage account module. And then we define different application settings. And you can see that all of these are like outputs from the Cosmos DB module, because we need the connection string and the database name and endpoint, all of these for our backend to run. And we get that from the output of the Azure Cosmos module. So this will be set up as the application setting for our backend. And then we have the vault access, API access to the key vault, just to make sure uh, our function app can connect to the key vault. We can use the principal ID because, like I mentioned, we can define the permission within the principal ID to access our key vault, and we give that permission to our backend. So that is how we create the permissions and key vault. And then this is for the database that we create. So we use the module, and you can see that the module source code is located in .app/db.bicep. So let's go ahead and check that. Um, if we go to module, and then let us actually confirm that. Give me a second. I can go to app and then db.bicep. So this is where we define our Cosmos DB module, and the actual Cosmos DB resources are within this module. So if you go ahead and click that, then you can see all the different resources of how it is creating a MongoDB database using the Cosmos DB API. All right, so that was for our database. So the database is now being created, and then um, we have the app service plan module. We also have a storage module. We also have a key vault module to store our connection string. We have a monitoring module in the same way. And we also have, I will come back to all of this in a moment. We have a API management module. And finally, we have the outputs of all the other modules that we need. And these outputs are also kept as an environment variable, and we can access those environment variable while this is being deployed. All right, so you can see that the deployment is already done because I ran the azd up command, and you can see that all the resources are created automatically. So we did not create any of this by manually. So remember that when I tried to create all of these resources, I never went to Azure portal at all. So all of this was created by Bicep for us because we defined the modules as well as resources and the parameters all within the code. So that is the beauty of Bicep or any other infrastructure as code tool for that matter. So it created the resource group, and then it created the static web app. And once those was done, it created the app service plan. We have the key vault, we have the log analytics, we also have a storage account, the application insights, and we have a dashboard, we have a Cosmos TV, and finally we have the function app. So all of these are created, and the order of this creation was automatically decided by Bicep for us. We did not have to worry about that. And you can see that I have now the link to both the backend and the front end of my application. So let us first try to see the front end. So I think this is the front end of my application, deploying services web. And then let us go ahead and open this one. And you can see that the application, we already have a domain or random domain created by Azure for us. And you can see that a to-do app is already up and running, and it's trying to load the list from the Cosmos DB that we have on Azure. So we will check all the resources one by one and see if we have everything up and running, because we can access the front end. And let us try to create a new list. Let us name it as test, and then item to be buy groceries. All right, and I will enter it. So you can see that I have a to-do item of buying a groceries, and I can add a description. I can have a status of to-do in progress or done, and then I can also have a date. So let's give DSA exam. So that's going to be, let's say, a second task, right? And then I can have that. I think I did not enter that one. So yep, the by DSA, and then get done with DSA. All right, for yeah, we have the to-do item here. And let's say for buying groceries, my status is in progress, give DSA exam is done. So you can have all the information over here. So for to-do list is working fine, but let us try to see if all of those things are working fine or not. So let me come back to the portal. And here you can see that I can get a detailed information of all the deployment services from the link. And if I click on that, and then I can open my deployment details, and you can see that on the deployment details, all of these services were deployed and the status is okay. That means everything was deployed properly. So let us go ahead and actually explore all these services one by one. So first, let us go ahead and see the web service, so which we just saw. So this was this was the front end service for our application. And you can see I can go to visit your site, and this will point me to the same URL that we just saw. So this is the front end of my application, and everything was configured by Bicep according to the configuration that we have provided. So here we have we have the environment variables. We can even set up a custom domain if we want. So all of these were done by um, the Azure Bicep for us. So next up, let us try to see the other services that we have. For example, okay, let me quickly come back. And here we have a API, right? So we have the APIs where we can also configure additional APIs if we want, but since we are already using function, we don't need to configure APIs separately in our case. So that is for the front end. So if I go back to the Microsoft Azure portal, and if I go to resource group, so remember we kept everything within the same resource group, and this was GSW serverless demo for our case. So here you can see that it has created 9 different resources, and we already saw about the static web app. So next up, let us go ahead and actually see the function app, which hosts our backend, right? So I have opened up the function app. Let us go ahead and see this. And then you can see that the function app is also already up and running. The status is enabled. So I can actually go ahead and browse this to see all the API endpoints that we have in our application. So you can see that we have all the different endpoints. So these are for getting the list of the to-dos, or get a list of to-do by any unique identifier. We have the route to delete them, to put them, all the basic CRUD operations. And then we also have a lot of other routes for getting the specific list item by different ways. So these are the different endpoints, and it's using Swagger to just generate this list. And we have the schema for our different items. we have the schema for our to-do item, we can get the schema for our to-do list, and we can also get the schema for our to-do state. So right now we have three different states. So you can see that the status was to-do. If you go ahead and click on the URI and click on any specific item, the state had three different states, right? So you can confirm that from the to-do state schemas as well. And to-do list has these three parameters, and to-do item has also these three specific parameters. So that is for the to do item. And now let us actually go ahead and see the function. Let us see the actual functions over here. So if you go ahead and click on log stream, you can see the logs of the backend over here. And it's trying to connect to our application inside. So let's wait for a few moments. It's now connected. So if you have some errors in your application, or if you want to get the log of your application, then you should be able to see that over here. And you can also see it's a file system log, or you can also switch to application insight log. So it depends on what type of logging system you want, and then you can always switch that over here. So next up, let us try to see the environment variable. And I wanted to show you this because um, let us go back to Azure Bicep, and then let us try to see how we set up our backend, right? So let me come back to here, and this is main.bicep, right? And here you can see that the application backend, we had set up the Cosmos DB connection string, the Cosmos DB name, the Cosmos DB endpoint, the API allow origins value, and also the key vault and all those things to configure our backend. So let us see if those are actually over here. So you can see that the Cosmos DB connection string, the Cosmos DB database name, the Cosmos DB endpoint. So all of these are already added as the application string within the application settings, right? And this is done. If you go to the Bicep file, you can see that these the Azure Bicep got these values from the output of another module. So for example, it first created the Cosmos DB database, and then within the output of that module, it had a connection string, and it injected that value as the application setting over here. And that is how we are going to get that value in application settings. So for example, in Cosmos DB connection string key, I can see the value, and this is the string value. For the database name, that's the value of the database. To-do is the name of the database. The Cosmos DB endpoint, this is the endpoint. And for the vault endpoint, this is the specific vault endpoint. So all of this is created by another module for us, and the output of that module is passed as an application setting to this module as an environment variable, because our application needs that. So that is for the function apps. And right now we don't have a CI/CD configured, but we will do that in just a second and see how that works. And the API management also is right now turned off, so we don't need that. Our front end can directly talk with the function app for now. So that is done for the function apps. And we also saw the React application from the front end. The other thing that I want to show you is Cosmos DB. Let us go and see that next. So let us wait for this to load. And this is the Azure Cosmos DB. And this is actually the database that is compatible with our MongoDB service that we need for our backend, right? And you can see that the database is up and running. The status is online. It's within the same resource group that we have defined. And if I go to collections and browse, I can see the list of all the collections. So I just have two collections over here, the to-do item collection and the to-do list collection. But to see the data, I can go to Data Explorer. And here I can close that, and I should be able to see the list of to-do item that we created. So if I go ahead and click on the to-do item collections, and then I can click on documents, then I should be able to see the list of to-dos that I created previously. So yeah, you can see that I have different document IDs, and if I click on one of them, then yeah, you can see the actual JSON of the to-dos over here. So this is the to-do item that I created, and I can click on another one, give DS exam, and something else, buy groceries. So these are the to-do item that we created, and I can see the schema, preview, and everything. I can also check the settings for the collections and all those things over here. So this is how I can explore the application from the Azure Cosmos DB. And remember that Cosmos DB comes with a lot of features, but we can always just use the feature that we want. So we don't need to make our application super complex. In this case, we are just using the MongoDB API to make sure that the application works with our backend. So that is for the Cosmos DB. So we searched and checked about the static web app. We searched and checked about the Cosmos DB, which is running fine. We also checked for the function app, which runs our backend, and it's a serverless approach. So it only runs whenever there is a specific request for our front end. So remember that all of the routes that we have defined within the function app, so it only invokes. So if I go here and click on the catch all function invocations, you can see that it gives us list of all the invocations that we have. So whenever there is any invocation or request from the front end, only at that specific time, the API request will be executed. So that means our application is not constantly listening for the front end request. And only when there is a specific request from the front end, at that time, the function will run. So we will only be billed, or our credits will only be used only for the time that is needed for the function API to run. So for example, you can see that in total till now, I had 22 invocations, right? So these invocations could include the listing the to-do items, or adding the to-do items, or creating a post request, or creating a delete request, or anything like that. So for example, if I go ahead and actually delete this right now, let us actually delete this right now. All right. So I deleted that. So there should be an increase in the number of requests over here. So if I refresh this, uh, yeah, it might take some time to load, but this should be um, it only invokes for the time that we have used. So right now you can see that previously until now we had 22, but that will increase in a moment. um, it only ran for 400 milliseconds or some other specific milliseconds, right? And you're only built for this specific time. So if you have an application which do not need to listen constantly, like a web server, for example, so web server normally has had to listen all the time. So it makes sense to run that within a VM or a container, or some other managed service which is up and running all the time. But for applications like To-Do, only your front end needs to be active all the time, but your back end, which actually stores the To-Do or get the list from your To-Do, it makes sense only when the user requests it, or when a user wants to add some item, or when a user wants to review the To-Do list. It makes sense to just give them the information at that time. So that is a great use case for a serverless approach. So whenever you want to do something based on certain events or invocations, that is where the function or event driven architecture comes into play. Think of another example. So you can see now the count has increased to 24, right? Because I added or I deleted the data. So you can see that that request was the count has increased from 22 to 24. All right, so remember that you have an application and you want certain things to be based on certain events. That is a great use case of Azure serverless and the Azure functions in particular. So let's say you are building a application where you are uploading some image and you are doing some modification to that image before storing it in your file server or image repository. So that is also a good use case for serverless. So you can combine serverless approach with the VMs or other managed services approach. So for your web application, you could use a managed web service or a VM, but just for the part where you are um, doing something to your images or files, or you want to send some emails to someone, or you want to do some push notification for your mobile application, then you can use serverless or Azure functions for those specific use cases. So that is how we do that normally in production. So for example, you want to send an email to a client once you deploy their services. So that is also a good example of when you want to use serverless function, because you can trigger it based on the deployment status, and once the status is passed or checked, and then you can configure it to trigger another function which sends the email to the client. So that is how it works. So let us go ahead and check the other resources that we have now. So we checked the Cosmos DB, we checked the function app. Let us go ahead and actually check the Key Vault. Because remember, for the front end, if I go to function app again, and within the environment variables, I do have the connection string key and all those things, right? But these are some of these are stored as a secret, and we reference that over here. So you can see that we have the connection string over here, and this is stored as a secret in the key vault. So you can go to object and secrets, and then you will be able to find the connection string here. And if I click on the key vault key, specific key, and then it comes and you can see the actual secret over here. So here is the actual secret value. So this, all of this entire thing is the MongoDB connection string, and we reference that Azure Cosmos connection string, Azure Cosmos connection string within the environment variable for our function app, because function app is storing our backend. So remember the key name. The key name was Azure Cosmos connection string, and here we have the Azure Cosmos connection string, and then the value is not the actual secret itself. Remember, the connection string, this is the name of the key in the key vault. So our application is more secure now, because within the environment variable we are not exposing the string key. So this is the actual string key. So actual string key, if I paste it on the browser, so this entire thing is the actual key. But in the environment variable for the function app, we are not storing the entire key, but we are actually storing a reference to a key in the key vault. And the application or the function app can in runtime bind the value of the secret uh, through the name of the key vault secret name. So that is how our application can access the key vault uh, key and finally connect to the Cosmos DB. So that is how it works for the environment variable and how it connects to the Azure Cosmos DB. So next up, let us try to see what other resources do we have. So let us go to resource group back and open the resource group again. So I hope that is clear till now. So next up, let us go ahead and see the application inside that we have. All right, so let us wait for this to load up. So this is the applications insight, and you can see a lot of different metrics over here. So you can get the data for the last 30 minutes, 1 hour, or set up a custom range if you want as well. And you can see the number of failed requests. We don't have any failed requests, so the count is 0. The average server response, the average server response time. So you can see that the server response time initially was very high of 13.6, but then this was during the initial setup when the things were still configuring. But now the average response time is around 100 to 25, so it must be somewhere around 100 milliseconds. And then we have the number of total server requests. You can see that the total count to the request has been 55. The availability of our applications and everything, you can see it over here. You can get different metrics from the monitoring tool. You can check logs. You can enable it. Right now it's disabled. You can check the data about the different users. Right. So right now, for me, it's just counting 2 of my tabs as 2 users. So the user count is 2. So you can see the number of active sessions, the events. So all of these are the beauty of the application inside. So you can get information about all the different things, from number of users to sessions to what happened in your application to different metrics. You can even set up alerts if you want, but I'm not going to use that today. So next up, let's go ahead and check the dashboard, because this is also really cool and interesting for me. So let's go ahead and dashboard. And here you can see everything that you just saw and a lot more in a single dashboard. So we saw the failed request previously as well, and the server response time, but it has a lot of other things within the same dashboard. So we can use different application metrics and combine them within the same dashboard. So for example, for the users category, we have like 2 users right over here. We have the reliability metrics, we have the responsiveness metrics, and you can see the number of unique sessions and the number of unique users. So it's 1. um, Here you can get the actual value, because previously we saw 2 as the number of user, but you can see the unique users over here. And then you can also get the failed request count, the server response count, and this is also really cool metric that you can get from dashboard. The average process and CPU utilization is just around 3 or less than 3, around something like 1 point or 0.938 in this case. So that's very good utilization. So that is really a good information, the average IO rate and everything, the average available memory. So all of these you can get inside. So for example, your CPU utilization is very high, let's say around 80%, then you know that you don't have enough CPU. And in that case, you can add the number of CPU or increase the capacity of your Azure Function app. So that is how you can handle all of the things. So you can configure your dashboard as you want. You can edit it. You can see, have different sort of graphs and marketplace applications and all those things. So that is about the Azure dashboard. So let us go back to our resource group and see what else do we have. So for our serverless approach, we saw the front end, we saw the back end, we saw the database as well as dashboard and the key vault. So that is most of the thing that we need. And for our back end to store its data and the actual application code, it needs the storage account. Storage account is nothing but a collection of all your different storage services, and it all your storage services, whatever you're using, whether it's a blob service or a file service or anything, it needs a storage account. So here you can get an overview of what is enabled and what is not. So we have enabled the file service and not the other ones, because blob service is disabled, queue service and table service, we don't need that. But we need the file service. So you can go ahead and click on file service. So that is enabled by now, and it's using this one to have our application code and all those things. So let's go to storage uh, and events. You can see that right now we don't have any events, but based on certain activities within your storage account, you can configure your event over here. So overview, that was the quick overview of the storage account. Let us go ahead and actually check one more thing that I want to show you, and that's going to be the log analytics service. So let us go ahead and click that. So this is required um, to query different application logs and metrics. So for all our monitoring tools such as application insights and all those things, we need the log analytics service to be enabled. So this is also required for our other services, hence we need this specific service. So if I click on monitoring and insights, you can see that we do have some data over here, but it's not, since the application is not running for a long time, we don't have those data right now. So this is for the resource group and the serverless demo. So our application is up and running. So you can see this is the backend. You can even try, this is the Swagger UI. So you can try the routes. So let us go ahead and try this out. And if I click on execute, then I should be able to get the list of items here as well. Yeah, it's loading. It might take some time to connect to the backend, but we should be able to see the actual list over here. All right. We have one to-do item and one done item. So let's see if this works. Not sure why this is taking a lot of time. It should not be taking this time. Ideally, let me quickly refresh the Swagger UI. All right, let me close that again. Let me open that up again. And here we get, try it out, execute. Yep, and we do get the list of the array over here, the array of to-do list. And let us also get the, you can see that we do have one list of my list, and you get the name of the list, which is my list in this case, you get the list. But if you want to get a specific to-do item from the API, then we need to provide it with the name of the ID. Let us copy this one, and let us use the list/list ID and provide it with the list ID parameter. All right, I will provide it with the parameter, and now I should be able to get the name of the list. And if I want to get the specific items, so let us go ahead and do this. I will provide it the name of the item, and if I try to execute this, yep. And in the response body, I do get the data about the specific list. So this is how I can get different items and the details about the different to-do list from the Swagger UI. And now let us go ahead. This is the front end that we have created. So remember, the focus of today's stream was to showcase you how you can use, or the power of infrastructure as code tool and Azure Developer CLI to deploy application in a serverless approach. So that is already covered till now. Let me check and see if we have any more comments. Yep, you are more than welcome. And I hope you are also enjoying or learning some new things over here. Bear with me for the streaming issues, because I don't have a secondary monitor right now. It just broke down before the weekend, so I could not get a new one. So I will be hopefully able to get a new one before the next Global Hack Week, and then things should be much more smoother. So yeah, I hope you can still see my screen though. Sorry for the hiccups in between. So let us actually go ahead and try to understand all the things that we have done till now. I'll close everything till now and just do a quick recap before we move on to the CI/CD part of our application. All right. So the things that we have done till now. So let me go back to the slides. Um, All right, so this is the actual repo, right? Give me a moment. Yep. So this is the structure of our application that we want to deploy in Microsoft Azure. So we had this static web app in the form of React application, and we use the static web app to deploy that. We have a Node.js application, and we use the serverless approach of Azure Functions to deploy the Node.js app because we wanted the Node.js APIs that handles the to-do request only to run when there is a request. So that means the API server is not listening 24 by 7, but is only executed whenever there is a request. The request could be anything from get to put to post to delete, whatever you want the API request, but the function will only run whenever there is a request. So we will only be billed for the time of the duration that the API routes text to execute and return the result. So that's the power of function app, and it's used for event-driven application. And then we had a storage account to store the application code and all the temporary files that that function app might need. We have MongoDB supported Azure Cosmos DB API. So since we don't have a native Cosmos DB, native MongoDB service in Azure, so we need the Azure Cosmos DB, and but it supports the MongoDB API. So we can just use that without any modification to our application code. And then we are using the key vault secret to store our connection string for our database, and we inject that secret to the function app application setting as an environment variable. And then we are using the Azure Monitor to monitor different things like CPU and memory utilization, the number of active users, the connections, the field request, and all those things that we need to get more insight to our application. So that is all that we did. And we did all of that using Azure Bicep and Azure Developer CLI. So this was the repo that we got from Microsoft Samples. We created a repo out of that in our own account, and we cloned that. And the source code of our application is within the src/API folder. So this is for the backend of our application, and we have the front end of our application within the web directory. And then we define the bicep commands and instructions within the azure.yaml file. And within the azure.yaml file, we define the different workflow. So this will basically run the AZD provision and AZD deploy to provision all the services that we need and to deploy them. So first we define the services. So first we define the web service, which is the front end. So we have to give it a path of the front end location. So it was actually src/web. So we define the path. We need to give it a directory where the build assets will be present. So that's going to be dist for React application because we are using Vite as a bell tool. And then the JavaScript as the language, the static web app because we are using static web app to host our front end. We are using some hooks to create or inject the environment variable to our front end build. So we need to give it the API URL for the front end to connect to the back end. So we get that from the output of the module API base URL, and that will be present as an environment variable, and we use that to create this environment variable. And likewise, we do the same for the application inside connection string. So we get that from the output of the application inside connection module, and then we create environment variable and pass it to the front end build. So that is what all we do. And then we finally remove the temporary env.local file. And likewise for the API, which is the backend, we define the path to the backend. The language is again going to be JS because it's a Node.js and TypeScript application. And then we define the type of backend service that we want. So in this case, we are going to use the Azure function. So it's going to be function. So that is all that we did. And when we run the azd up command, so first we authenticated with the Azure portal with the help of azd auth login command, and then we use the azd up to spin up all our application. And to do that, it is using the infrastructure folder, and within the main.bicep, we define all the resources that we need for our application, right? So we have different parameters that we need. So some of the parameters are empty string by now, but some of the parameters we construct that out of other combination of other variables. So we have parameters, we have some variables, and then we define different resources. So the first we need the resource group, and then we define the front end, which we already saw. It's using the web module, and then the modules is nothing but a collection of different resources. If you want a more detail, just control and then click on this one. So it will take you to the source of the module, and here you define the actual module, and this depends on another actual module. So if you again click on control then, and finally you reach to the end, which is the actual resource itself. So module behind the scene is a collection of different resource, and it has different outputs. So, and one other information that is really important for you to keep in remember is that, for example, when we want to deploy our backend, we are using the API module, right? So api.bicep, and you can see that if you go ahead, it's using the functions.bicep file, and if I click on that, it has different resources. It is again depending on some other module, right? So it can be on multiple hierarchy level. If I click on that again, and finally I can see the actual app service resource over here. So this is the final endpoint, but we have a lot of abstraction layer on top of that. So for example, the thing that I wanted to show you is that we need this parameter to pass to our backend, but we can use the output of other module as an input to the parameter of another module. For example, for the application insight name, we need the application insight service to be already up and running. And for that, we create the application insight service within the monitoring module. And if you go ahead and click on the source of the monitoring module, we have the application insight name as the output of this module. That is why we are able to, if you go to main.bicep and then go to backend, you can use that output as a parameter to this specific module. So that is how we did all of this. For the app service plan, it creates the app service plan module first, and it uses the output of the ID over there. So this is also how you can define the dependency, because whenever Bicep sees that, okay, this module needs the application insight name, and it is referencing the output from another module. So Bicep automatically creates this module first and then gets it output to apply to this module. So this module will only be created once all the dependent modules are created, and then we inject all of these settings from also from the output for the modules. So all of these are also done, and we can confirm that by going to portal. For example, API allow origins. It is creating from the web output service web URI. So if I go to application setting, once again, if I go to the portal and if I go to the backend function, let's go open the function API. And if I go there and click on the settings and environment variables, so I should be able to see the same variable over here. So you can see that we do have the API allow origins application setting and the name as this one, because our this is actually the URL for our front end, because normally only the front end should be able to communicate with the back end. So that is why only the front end URL is kept as allow origins, because if you make a request to the function app directly apart from anywhere outside the front end, it will not run, because we have only kept the allow origins to be the front end of our application. So only this can make the request to the back end. Yeah, and you can just confirm this is the same URL for the front end, because yeah, it loads the front end. It's just the URL for the front end, so only front end can communicate with the back end. So that is why we have kept it as in the API allow origins list. So that is how we did that. um, and likewise, we created the vault, we created the database, we created the app service plan, we created the storage, we created the vault again, we created the monitoring service for dashboard and all those things. All of these are over here, and all of these outputs, these are also exposed as an environment variable because we need them later on. All right, that is done. So let us go ahead and now configure the CI/CD approach, because right now if I make some changes to my application code, let's say if I want to go ahead and go on the front end, and if I go to SRC, and then let's say if I go to home page, right? And then in the home page, we are using different components, and then default list. I want to change the name of the default list to, instead of my list, let us name is as GSW default tasks, right? So let's say if I want to change this right now. So right now, if I change this and commit this to the GitHub repo, nothing happens, because the application is already deployed. So even if I push this, change this to GitHub, the URL of my application, when I go over there, it will still show GSW default tasks. So I want to change that. So that is why I can use the GS. Let's say I want to delete all the to-dos that I have over right now. So I will delete everything that I have. I'm going to delete this. Yep. And I'm also going to, like, this is the default list, the my list, but I want to change the name of the default list to GSW. All right. So if I commit it right now, let's say git add, and then I will commit this change. So instead of change default list name, and then I post these changes. Right. Yeah. Okay. The changes are now pushed, right? So if if I go to the GitHub account and if I refresh this one, obviously the default list, I can see the commit over here, right? And some actions are trying to run, but they will fail because we have not configured the CI/CD pipeline. And if you go to the front end of our application, give me a second. I need to find the URL for that. The front end. The front end is in the static web app, and if I click the app, the name is still Miley, so nothing happens. So let us try to automate this process. So for that, I need to use AZD and pipeline config. And for provider, you can either use Azure DevOps or use GitHub Actions. But since our application code is already in GitHub, it's recommended to use GitHub Actions. All right. So let us go ahead and configure the pipeline. So what this will do is to create a service principal in our Azure account so that Azure can connect with our GitHub repo and GitHub repo can connect to the Azure service, because whenever there is a change in the GitHub repo, we need that change to be reflected in the Azure app service or the Azure static web app. So that means our GitHub repo should be able to authenticate and deploy the changes to Microsoft Azure. That is why we need to create a service principal, because in service principal, we can define the permission to our specific repo. So it will create a federated identity credential and add that to our repo. So you can see that it has already created this environment as a secret, and it will add that to our repo. And um, I would like to show you how that is done. So I'll just click on yes to commit all the changes to the pipeline. Yeah, now the pipeline is configured, right? So if I go ahead and check the repo now, let me go ahead and check the repo now. GitHub repos. Yep, GSW serverless demo. And now you can see that the action is now running. The new action, which is just triggered right now after I run the AZD pipeline commit. And you can see that we have a new GitHub/workflows folder, azure.dev, and this was committed previously, but we did not configure anything previously. But now you can see that it's trying to access the Azure client ID, tenant ID, subscription ID, and credentials ID. And you can see that mainly the Azure credentials, it's trying to access that from secret, right? And if you go to settings, and then secrets and variables and actions, you can see that we do have environment config created, and this was updated 1 minute ago, and that was done by Azure first, because when we created the service principal, we provided our repo access to Azure, and also Azure can also access our repo. So it's like two-way interaction. And then the values is created. So if you go ahead and check for this environment variable in the workflow, we should be able to see that. So let us go ahead and check the pipeline and Azure Dev, Control F, and you can see that the AZD initial environment config is configured to read the data from the secret, and the secret is also added by the Azure environment. So that is why it's able to connect. And now if I go to actions, you can see that the pipeline is running and the build process is already started. And you can see that it has already started to do all the things that we did previously. So is it the provision and everything that we did previously? So it is now provisioning all the infrastructure that we deployed. And now once the infrastructure is deployed, it will deploy our application. So whatever we did manually, so we let previously we used the, remember we used the AZD up to provision our infrastructure and everything. So it is now configured in a pipeline, so you don't have to apply AZD up from your CLI. So whenever you make changes either to your infrastructure or to your application source code, nothing, it does not matter, because everything will be now done by GitHub Actions for you. So you don't need to apply AZD up by yourself. So you can see that it's trying to provision the infrastructure, but since the infrastructure is already provisioned, because we did not make any change to the infrastructure, right? So you can see that all of these executed very fast. Otherwise, if this was done for the first time, then this would have taken a lot of time. So that is now done. And now now once the infrastructure provisioning part is done, it will deploy our application. So let me come back to the stream and see if we have any comments. All right, we don't have any new comments, so let us go back and Let us try to see if this works. So the infrastructure part is done. So Bicep is now trying to deploy our application with the help of GitHub Actions. So the Bicep part is done, and we are now using the AZD deploy command. So it's trying to install all the dependencies, copying the deployment script and everything. And once this is done, we will also take a look at the workflow file to understand this in a bit more detail. So once this is deployed, and if I go to the front end, I should technically be able to like see the GSW tasks instead of my list as the default name. So right now it's still my list, right? So I changed something in the front end, and let us just wait for this to complete, and we should be able to see the new thing. So that is how we can configure an end-to-end CI/CD pipeline. Sorry for the hiccup with the streaming. I was just having some weird issues with my monitor. Okay, so this is, you should be able to see my stream, I guess, again. Yep. And then now the AZA deploy is running, so we just need to wait for this to complete, and then we should be good to go. In the meantime, let me explain you how this is actually doing the deployment process, because we can see a lot of steps happening over here, but where do we get the steps from? So you might be wondering that. So I will exactly explain you how that works. So it is getting that from the workflow file that we define over here, and we define that within the .github/workflows folder. And here we need to write the workflow file, right? But Azure already had that in their sample, so it's using this one. So here first we define the trigger point. So here we define when the workflow should be triggered. So first we have the workflow dispatch, which means we can also trigger this manually from the button in the UI, or it is triggered whenever there is some commits pushed to the main branch or the master branch, which was named previously. But now, whenever there is a new change or commit pushed to the main branch, then the workflow will run. So this is defines the event when the workflow should run, the CI/CD workflow, and we give it permission to write. This is needed for the JWT token, which is needed for our authentication between Azure and the GitHub repo. And then we also provide it with the read access to the content of the repos, because the pipeline needs to be able to access the repo content. That's why we provide it with the read access. And then we define the different jobs. So here we have just everything within a single job of build, and it defines the runner where the workflow should run. So that's going to run on the Ubuntu runner. Runner is nothing but a server which runs the workflow, and this server is different from the server in the Azure VM that we created in part 2. This is a temporary server which is created by GitHub Actions for itself, and it is only created until the job is to execute all the steps that we have in this job. And once this job is done, it will delete that server by itself. So it's just a temporary server to run the different steps. And we define the different A and B variable, and these three are taken from the variables if we have defined that. But the Azure credentials is taken from the Azure credential secrets. And here you can see that we first check out the application code to just see the content of the application. We install the AZD, because remember, locally also we install the Azure Developer CLI. So we install the Azure Developer CLI, and then we install Node.js, we install the Azure Function Core tools and everything that we need for our applications. And then we log into Azure, and we log into Azure using this different kind of commands, using AZD auth login. And then finally, once we log into Azure, then we use the AZD provision command, because normally we had the Azure.yaml file, and if you go here, then we are also behind the scene using the AZD provision command. Not in previously when we run it locally, we use the AZD up command, right? And behind the scene, this search for Azure.yaml file, and it executes all the steps over here, because AZD, and this is the workflow is up, so it executes this command. But in the workflow, for example, in the GitHub workflows, we are passing it one by one. So is it the provision, and then we pass it with different configs, uh, and then we finally run the izd deploy commands. But let us explain one more thing. I think that will make okay, the deployment has now completed. So we'll check the application in just a second. But before that, I want to show you one quick thing. So for example, if I go to secrets and actions, um, then I have the AZD initial E environment config as the secret, right? So control F and V, sorry, find. You can see that we only define the AZD environment config, right? But we don't have the um, environment name and Azure location and that. And this is automatically set up when we do the AZD login, because once we have the login, once we log into our Azure command, then we can, it automatically can access the subscription ID by itself. So that is why we don't need to pass it explicitly. And that's why we only store the AZD environment config, because that is the actual credentials which is used to authenticate between the Azure applications or services and the GitHub repo. So we just can use that only. All right, so that is done. So, and now our CI/CD pipeline is also running. So we should be able to confirm that. So let me go that, and you can see that the pipeline has executed successfully and everything is done. Deploy application, install, everything is done. So let me refresh the page, and it's still showing my list. So there should be, let us check if why is that happening. New list. All right, let us check the application code and see why this is not working. Maybe the React application is set up in a different way than what we expected. All right, so let's see within the pages, sorry, and home.pages. All right, it's still default docs, so I'm not sure why it's still showing that one. um, so let us go ahead and actually check the layouts and header. Okay, everything is fine over here. um, Models, to do item, or let us try to change something else then. Let us try to change the value of in progress to something else, or let us do make some else sense, because I think it's not referencing the name that we want exactly the way we want it. So we can change something else and to see if it's working properly or not. Or let's use the CSS, or let us try to do something else with CSS. All right, so should we change some CSS, folks? Let me know what we should change, and see, recommend me what we should change. Item actions. All right, components, and then to-do list pane or menu. Do I want to change the menu? Nope. All right, the placeholder should be new list. So let us try to change the placeholder to CSW new list. All right, let us change this thing. The placeholder should be CSW new list. So I will add this git commit, change default placeholder for list, and then let us post this. All right. So the pipelines will have been triggered again. Yeah, but it's gonna again take some time for this to complete because it needs to complete all the steps that it did previously. So we need to wait for a few more minutes and we should be able to see the change. Maybe like some other change was done, but we don't see the list over here. Yeah, okay, now we can see that, because we when we created when we kept the my list, then it already expected one list. That's why we did not see the change. But now when I deleted that list, the default list is here. So that means that the actions is running properly, and we have whatever change we do with our application source code or also the infrastructure services, that should be able to be reflected now. So we don't need to wait for this to complete. We already saw the change that we expected. All right, so that is done. I can again show you something just to make sure that the application list is working. All right, this is working. And we do have the new default talks and everything. So that is fine. And that is all for the demo. Today, I hope you all learned a lot. And this is how it works. Today, we used Bicep for defining the infrastructure and also the Azure Developer CLI to deploy them. And then later on, we used the Azure pipelines with we configured with the help of GitHub Actions to set up the automated CI/CD process. But you can follow the similar approach with also Terraform or any other application stack that you want. So this approach is going to be similar. This is the overall architecture that we used today, and I hope you enjoyed the 3 part of the series. Remember once again that all the resources that I have provided are still within the resources that I provided to you within the link. So make sure that you go ahead and check those resources out. You can follow along at your own pace, and also the sessions will be recorded and kept on YouTube, so you can follow along that as well. And if you have any questions, please put them in the comments, and I will be more than happy to help you out. All right, folks, bye bye. Have a great time, and see you again in the next Global Hack Week. Bye bye, folks.